in calculating the volume or finding the volume of these shapes? What did you do to find the volume of shape A? Caitlin, what did you do?
I did 5 centimeters, 2 centimeters, 6, I got 20, and I did length times width times height.
Okay, so you got 5 for the length. So 1, 2, 3, 4, 5. 2 for the width. 1, 2. 2 for the height. 1, 2. And you said 5 times 2 times 2. 5 times 2 is 10. 10 times 2 is 20. So the volume is 20. You guys get 20? Good, because that's what it is. Selena, what are you saying?
Oh, no, it's just
Oh, did anyone find the volume a different way for A? Or did you all do length times width times height? What did you do? Okay, so what Serena said is she did do this, but she checked it by counting the front. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you've got 10 on the front, you've got 10 on the back. And 10 and 10 is 20. Can you do it that way too? Yes. Or I can also look at it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the hello marker. 10 on the top. And if you've got 10 on the top, you've got 10 on the bottom. 10 and 10 is 20. So either way, as long as you get 20. So for finding the volume of B, Selena, what did you do?
So for my length, I got 3. For my width, I got 2. And for my height, I got 4. And then I took my length, which was 3, and my width, which was 2, and multiplied those together, and I got 6. And I took my height, which was 4, and multiplied 6 times 4, and got 24.
Very good. So she said 1, 2, 3 was the length. 1, 2 was the width. 1, 2, 3, 4 was the height. 3 times 2 times 4. 3 times 2 is 6. 6 times 4, 24. Is that the only way to do it? No. Now, when you've got the cubes, that's not the only way to do it. Now, pretty soon you're going to see just solid shapes, and you can't really count stuff when you've got a solid shape. So, like when I'm saying solid shape, if you look at the back, you don't have little cubes to count. They give you like a rectangular prism, and you can't count centimeter cubes. So, it's good to know the steps to find it. Okay, so you could also look and see that you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you've got 12 on the front, 12 on the back. 12 times 2, 24. Or 1, 2, 3, 4, 5, 6. We've got 6 right here. We've got 6, 6, 6, 6. What's 6 times 4? 24. You know, there's more than one way to find volume when you've got these cubes that you can be counting. So right here you've got C and D. So what was the volume of C? What was the volume of C, Rory?
The length was 4, the width was 2, and the height was 4, and I multiplied 4 times 4 is 16, and 16.
Good. So you said that the length was 4, the width was 2, the height was 4, and so the length times the width times the height. Now, you don't have to do 4 times 2 times 4. You just went, oh, 4 times 4 is 16, that's easy. And then you brought the 2 down, 16 times 2 is 32. When you're multiplying, you can multiply them in any order. You don't have to go left to right, so that's okay. So volume is 32. You can look at this in multiple ways again, where you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 in the front, 16 in the back. 16 and 16 is 32. Or 1, 2, 3, 4, 5, 6, 7, 8. You've got 8 here. You've got 8 there. 8 there. 8 there. 8 times 4. 32. No matter what, you've got 32 cubes there. What is the volume of D, Johnson? I'll put down the spot. What was your length? What is your length? 4. So your length is 4, your width is 3, your height is 3. So what is the volume? So 4 times 3 is 12. 12 times 3 is 36. Okay. So that second part with number 2 is telling you write a multiplication sentence that you could use to calculate the volume for each rectangular prism. You already did that, where it was the length times width times height. We did that because they were kind of assuming that some people would sit there and count all the cubes. Yeah.
So for A, B, C, and D, all the volume were multiples of, solutions of 4.
Products are 4. I wouldn't say they'd be a quotient because a quotient is the number you get when you divide. It's okay. Product. So calculate the volume of each rectangular prism.
Include the units. Some people are very picky. What? Some people are very picky about whether or not you write the units. It's a good practice to have. So see if you can figure out the volume of A and B. Kira, what did you do for A?
Excuse me.
Because 4 times 3 is 12, and 12 times 4 is 48. What?
Inches.
Cubic inches. Because it's inches times inches times inches. We have 3 times that we're using the inches, multiplying the inches. So it's inches to the 3rd power. Cubic inches. Okay? The volume of this wonderful rectangular prism right here. Sheldon! Did he say it right? You so twice. 36 what? No inches on there. What is that? Meters. Cube. We all say 3, you say cube. Meters to the third power. Cubed. Tyron is constructing a box in the shape of a rectangular prism. To store his baseball cards. You don't have to draw that if you don't want to, because I might be better at drawing those than you. It has a length of 10 centimeters, a width of 7 centimeters, and a height of 8 centimeters. And I mean, it's not like you can't take the information and go, oh, length 10 centimeters. Writing the information down. What information is it giving me? What information do I need? I need the length. I need the width. I need the height. That's all that you need to find the what?
Height.
Volume. What is the volume of the box? Which means, how many baseball cards would you be able to put in there? Well, I wouldn't really, because a baseball card is more than a centimeter, but Serena. Let me see. 10 times 7 times 8. What did you multiply first? Okay. Centimeter times centimeter times centimeter. Cubic centimeters. I would have done 7 times 8, 56. Mr. Doe. 56 times 10. Oops. 560. Just because we do it in first quarter doesn't mean it goes away. Do you have a question, or are you just like here, ready to do this when the next question comes up? Huh? Aaron says, more information is needed to find the volume of prisms. I can't deal with the box. Explain why Aaron is mistaken and calculate the volume of the prisms. Aaron says that more information is needed. Is more information needed to calculate the volume? Think about it for a minute, because y'all are like, no! You have to be able to tell me words. You can't just say no. You can't just say yeah. You have to explain. Maybe think about it for a minute. I know some of y'all are like, oh, and some of y'all are going, I'm waiting for them to say it, because I don't know. How many of y'all have absolutely no clue as to whether he's right or wrong? There's no shame in saying you don't know, because y'all know how many times I go, I don't know. I say it a whole lot. How many of y'all have no idea if Aaron is right or wrong? There's no shame in saying you don't know. Okay, Kira's like, I don't know. Y'all like, I have no clue. There's no shame in saying I don't know. It's better to say you don't know than act like you know and be completely wrong and screw it up. Right? I know some people that work downtown that screw things up all the time. Okay. Okay. So, if you know, awesome. If you don't know, I want you to think about this little guy right here. What do we know about this little guy right here? Now, the guys that don't know, you guys that do know that Why is Aaron wrong? Now, you guys that do know and already figured it out, I don't do this because that's why no one ever answers any questions. You don't give anyone any time to figure anything out. I love you, but you don't give people a chance to figure stuff out. If you have absolutely no idea, I want you to kind of, figure stuff out. If I just blurt the answer, you're never going to figure anything out. Look at this guy. This dude named Area, okay? Look at this guy. This little dude over here called Area. What do you know about Area? Think about it. Okay? If you still don't know, if you don't remember, you learned it, not this year. We kind of touched on it, but you didn't learn it this year. You learned it when? Was it just 4th grade? Okay, well, it's been a while. I know you didn't learn it in 2nd grade. I didn't teach it in 2nd grade. Okay. I can't tell you how long it's been since I taught 3rd grade, and it's been a while. That was before they changed the curriculum. So, did you figure it out, Sheldon? Okay. There are some very specific ones that you have to do for that. So, is there enough information on this shape to calculate volume?
No.
Why? How is it possible if they give me the area and a side that I can still figure out the volume? Why?
Because area is the length and the width multiplied. So the last number would be the height. So you multiply the area by the height.
Because area is length times width, and then volume is length times width times height. So the other number has to be height. Now this one, yeah, it's on its side. So what? All I gotta do is just like maybe turn it. Can't the shape kind of fall over? But when we multiply or add, can't we take our numbers and kind of move them around?
Yes.
It doesn't matter what order we do them. What I know is that the area is made up of two numbers that we chose to multiply together. So whatever two numbers that they multiply together, whether it's this side and this side, this other side is not used. So we took these two, they were 60 times 5. So don't get hung up on, but that's the width. Take the shape and flip it if you have to. And make it the height. Because couldn't I just take this shape, not ship, this shape, and just take it and turn it to where that is the height. Don't get so concrete and literal with the shape. You know what I mean when I say concrete and literal, where you're looking at it and going, but that's the width. I can take my numbers and move them around when I multiply. Didn't we do that on one of our other problems where she went 4 times 4 because they were easier to multiply? So she did length times height and then multiplied the width. Isn't that what we're doing here? Same thing. So the volume on this would be 300. So we could do it because the area is made out of length times width. And then you just have your other measurement. Does that make sense? James, you're kind of scrunching up your forehead. You're going to give yourself wrinkles like an old man. Does that make sense? Okay. This, they're giving me the area and the height. So I'm getting the area of maybe this surface and the height. They were giving me the area of this surface and then the height of whatever. So can we figure out the volume of the entire shape? Yes. Because the sides are squares. It doesn't matter. Because if this is 5, this is 5, this is 5, this is 5. All of the sides are the same size anyway. Because the sides are squares. Yeah? No? Maybe?
Yes.
So, with the volume being length times width times height, they've already done the length times the width part. So this would be 12. It doesn't matter if it's 12 times 1, 3 times 4, 6 times 2. Did they ask that?
No.
Nope. They're just asking, can you figure out the volume?
Yes.
Yeah. Oh, I didn't mean to do that. 20. My bad. I'm sorry. 20. I was looking at the 12 and my brain got stuck on 12. It doesn't matter if it's 20 times 1, 5 times 4, 2 times 10. It still doesn't matter because they didn't ask. Yeah. Well, because you've already got inches squared. And this would be like inches like that. 2 and 1. Still inches to the third. And I didn't put my units. Bad me. This is centimeters. Good question. Centimeters squared. When you don't see a unit, there's a 1 there. $300. When you're doing volume, you're always going to have a cubic unit. Always. When it's volume, it's always going to be something to the third.
So